Hello everyone, welcome to my project. I'm Chandan from DKIT Ireland. Today I'm explaining you about the project Gaze Tracking with Head Pose Estimation. And let me show you the working of the project and get into the details later. Okay, if you see here, the program is detecting your pupil position and giving the corresponding coordinate values on this image. If you see, if my mouse is if the cursor is moving on different position of the image, here you would see 331 y axis 31 on y710, which is the position of my cursor. Exactly, the pupil coordinates are showing on the screen over here, and it is also saying where exactly I'm looking on the screen. And if I'm looking towards left or towards right, and if I'm blinking, and which part of the screen I'm looking at. If I'm looking at top right corner of the screen, and the image is inverted here and it's not mirrored, so if I'm looking right on the screen, it shows left on the image, and if I'm looking at left of the screen, it shows right of the image. So basically what it's doing, it's giving my gaze direction with the gaze point on the screen where exactly I'm looking at. So this project is mainly focused on education and with perspective to the students' behavior with lecture. So nowadays the student lecture interaction is being more thinned out because uh, because of this, the students are not able to focus on the studies or try to get good grades. And this software will help students and lecturer interaction go smoothly. Imagine if a lecturer delivering to the class and asking students if they have understood anything, or like if there is any feedback, or if they get confused in any part of the screen, so they can get the feedback. Most of the lecturers do try hard to get the response. However, not most of the students respond to this question because their inferiority and their uh, could be the carelessness, or could be getting feared of being pointed out on different factors. Yeah, so this software will help lecturers to know where exactly the student is looking on the screen, or if he is not looking on the screen, and analyze if the students are being attentive or if the students are confused, so the reason they are looking on that part of the screen more often, or they do not understand the content on that part of the screen. This could be this is actually recording the data here, which gives which part of the screen I'm looking at, the quadrants and left pupil position on the screen, right pupil position on the screen. By averaging these two x and y coordinates, we'll get the gaze point where exactly we are looking on the screen, and the direction coordinates here, nose endpoint and gaze endpoints. So this data which is being collected can be graphically represented. So when this was tested on different backgrounds, in brighter backgrounds, in brighter room conditions, and darker room conditions, it works, but not to the extreme point where the room is pitch dark and you're looking at the computer screen and it doesn't detect. And why did we integrate head pose estimation with gaze tracking? Because of something called as Wollaston's effect. If we see here, the eyes look exactly the same on both the pictures. However, the face direction is different towards left and right. So on the image frame, eyes might give you the same position or same gaze perspective. However, the face direction will be different. So that is the reason we integrated head pose with the gaze tracking, and it worked on most of the challenges which we considered during the development. It worked on all skin tones. It worked on different eyes, as well as like the color of the eye, gray eye, blue eye, dark eyes, as well as people who are wearing glasses, without wearing glasses. And it also worked on different age groups. To visualize the data, most of the tests were taken when the people were gazing at a YouTube video on a smaller screen, the minimal screen. So the YouTube video, which will be on the left part of the screen was divided into four quadrants. The top right corner will be the first quadrant, top left corner will be the second, bottom left will be the third, and the right will be the fourth. When the data was collected, when people were watching YouTube videos, the gaze data which was collected was more in second and third quadrants, which says the YouTube video which stays towards the left of the screen are being gazed more. So this is how the visualization of the data looks like. And it also worked on different age groups. And there was this guy, he is almost 70 years old with glasses, white skin, and gray eyed. So he was looking at the YouTube video, and his case data seems exactly the same as the other gaze data, which says the head position, however, says on the bottom of the screen more, because the head pose uh, depends on the data here. So the data says the gaze was more on third quadrant and a bit more on second quadrant, which was least on first and fourth quadrants. So this is how the data can be visualized. And the data which is not transferred anywhere, it can also be in future work, it can be used in network tunneling and saved in cloud or database, and can be accessed on a different client machine, which says here the lecture machine. If the case data is getting collected on the student's machine while running this program, and it's being transferred through the network tunneling and being visualized on lecturer's machine without asking or without interacting on a student's behavior, we can collect the data and get to know where exactly the student is looking at, and lecturer can easily identify what's happening with the class, how is the class understanding the delivery, and what changes he could do to perform better, etc. And this visualization is working with the basic pandas of Python, which can also be integrated with heat map visualization as a future work. And the heat map can be represented as the more red towards the center of the gaze and fading out to blue towards the extreme outs of the gaze, as well as the detection is too broad in this uh, program. However, I tried to narrow it down to lesser quadrants, but the accuracy seemed really grading out. So here it says just the four quadrants. You can also uh, filter out 2 cross 3 quadrants or even lesser quadrants by increasing the accuracy with basic computation and statistical methods. So this is just 2 cross 2 quadrant. You can also divide the screen into multiple quadrants and try to figure out the gaze and the direction of the gaze. And all the details of the project and test data are given in the link in the description. Please check out the project, and your feedback and suggestions are very much helpful for me to improve on the project. Thank you very much.